Okay, so let's talk about systems of three equations and three variables. First off, anytime you have an equation that you can divide or reduce by, you should do it. So this 3x plus 9y plus 6 equals 3 really can be reduced to x divided by 3x plus 3y plus 2z equals 1, which will make it a little bit easier. First off, we know how to deal with two equations and two variables, so my goal here is to combine two different sets of equations. We'll call this 1, 2, and 3. Two different sets of equations to eliminate the same variable. If I can do that, I'll get down to two variables, and if I do two separate combinations, I'll have two equations and two variables. And I can use my skills from the previous area to solve these. Now, when you're looking at these though, you should always be looking for ones that easily combine. So in this one, since there's a lot of small coefficients, it's not that hard. You can combine any of them. But if you're looking at number 2, for example, the y's are 2, 3, and 5, which are hard to turn into each other. Well, not that hard, but more multiplications required. Whereas when you see the x's, it's easy to turn a 1 into a 3 or 5. It's easy to turn 2's into 4's and 8's. So just keep that in mind. Here, let's cancel out, we'll cancel out z in this case. So I know that if I just add equations 2 and 3, that z will cancel out naturally. So when I do 2 plus 3, that's 2x plus y minus z equals 2, and x plus y plus z equals 2. When I add them, I get 3x plus 2y equals 4. Now I also know that I can multiply equation 2 by 2 to get the negative 2 to match up with equation 1. So negative or 2 times equation 2 can be added to my reduced equation 1 here. So that would be 4x plus 2y minus 2z equals 4, combined with x plus 3y plus 2z equals 1 to give me a new equation, 5x plus 5y equals 5. And again, if I can reduce, I should. So that means x plus y equals 1. Now what I will do is call these equations, these new equations, we have 4 and 5. Now notice this would look exactly like a problem we would have before. So if I want to combine those two, I need to get this to either be a negative 2 or a negative 3. So what I'm going to have to do is multiply this by negative 2 and negative 3. So we'll add equation 4 plus negative 2 times equation 5. So that's 3x plus 2y equals 4. That's negative 2x minus 2y equals negative 2. To get that, 1x equals 2. So that solves our first variable. Maybe I would have to divide normally here, but I don't in this case, and I can plug it back in to get y. So we've got x plus y, and x plus y equals 1, which means 2 plus y equals 1. So that means subtracting 2, y is negative 1. Now lastly, once I have x and y, I can plug into z. I know from equation 3, x plus y plus z equals 2. So I've got x plus y plus z equals 2. Put in my x and y. 2 plus negative 1 plus z equals 2. That's 1 plus z equals 2, which means z is 1. Now again, just like the last section, this equation goes in as an ordered pair of solutions. This is 2, negative 1, 1 as the solution set. So that's generally how these go. One thing to note, if they give you an equation already missing a variable, you already have one equation with just two variables, which will really allow you to use the other two equations to cancel out that variable as well, so it can save you some time. So if you have an equation already missing a variable, you want to cancel that variable out in other combinations. Now let's look at word problems. One interesting thing that comes out of this type of problem, we'll only do one, is that every parabola is of the form ax squared plus bx plus c. So this is a y equals ax squared plus bx plus c, which means if I have 3 points, I can actually find the unique parabola by creating a system of equations, by substituting x and y. That's why when you graph parabolas on your homework, you plot 3 points, it automatically graphs it for you, because it knows there's only one parabola that can go through 3 unique points. To do that, we substitute our x, y values into this equation. So I know 4 equals a times 2 squared plus b times 2 plus c. So we get the equation 4 equals 4a plus 2b plus c. That's our first equation. And then we repeat this process for the other 2 points. So we get 1 equals a times negative 1 squared plus b times negative 1 plus c. Means 1 equals a minus b plus c, which is our equation 2. And do it for the last point as well, negative 2, 5. 5 equals a times negative 2 squared plus b times negative 2 plus c. That is 5 equals 4a minus 2b plus c. Now the good thing about this kind of problem is that the c is always going to have a coefficient of 1. And because c has a coefficient of 1, it's always easy to combine. So to do that, I'm going to take negative 1 times equation 2 and combine it with both 1 and 3. Negative 1 times equation 2 is negative 1 equals negative a plus b minus c. Equation 3 is 5 equals 4a minus 2b plus c to give me an equation, which will be equation 4. That's 4 equals 3a minus b. Okay, so this is a new equation. 3a minus b equals 4. Easy enough. I'm going to do the same thing. Negative 1 times equation 2. But instead, this time, I'm going to combine it with equation 1. Which was 4 equals 4a plus 2b plus c, to give me 3 equals 3a plus 3b, which reduces to 1 equals a plus b. So now we'll call this equation 5 and the previous one equation 4. Again, now that I'm down to 2 variables, I can combine these two. They add up just very nicely. 4 plus 5. So 3a minus b equals 4, and a plus b equals 1, which gives me 4a equals 5. So a is 5/4. And once I get that, I can plug it back in to get b. I know a plus b is 1. So 5/4 plus b is 1, so I have to subtract the 5/4. 1 minus 5/4, or 1 minus 1 1/4, is negative 1/4. And once I have those two, I can plug them back in to get c. We know that a minus b plus c was 1 from the original equation up here, which means 1 equals 5/4 minus negative 1/4 plus c. That's 5/4 plus 1/4. That's 6/4, or 3/2. Subtract the 3/2, you get c is negative 1/2. Now, this isn't an ordered pair like the other ones. These are the a, b, and c in your parabola. So you need to substitute the values in to get the parabola. And I know I'm taking up room for the last problem. The last problem's pretty easy, and I think you can figure it out. So this is a y equals equation. Of course, a goes in front of x squared, like it has in the past when we deal with parabolas. Y equals 5/4 x squared. B goes in front of x, so minus 1/4 x. C is our constant, minus 1/2. So this is the unique parabola that goes through those 3 points. And that's really all for 5.1.